Hey, this is Charlie Thompson, and welcome to the quick and dirty intro to Lab 4 on temperatures. So in this lab, we are going to talk about temperature scales and conversions. We'll talk about wind chill, we'll talk about the heat index, and we'll talk about temperature controls, which is a fancy way of saying the reason some places are hot and the reason some places are cold. So the controls on temperature, we'll talk about average temperatures, which is every month added up and divided by 12, and temperature range, which is the difference between the hottest month and the coldest month. So temperatures versus degrees, there's a longer video of this that I've made. Please watch it. I just thought this is such a tricky concept for students, it's worth going over for another couple minutes. So there's a huge difference between temperatures and degrees, and the way you can tell the difference is look for the degree symbol. So temperatures, what it is, it's just like what it is outside, that's the temperature. Degrees are the number of degrees between two temperatures, and there's different formulas that we use for converting temperatures and degrees. Degrees is the degrees between temperatures. So the first one is degrees Celsius. That's a temperature. And the second one is Celsius degrees. Those are a number of degrees. And the way you can tell is where's the degree symbol. If you read it as whatever degrees Celsius, that's a temperature. Celsius degrees are a number of degrees. Degrees Celsius is a temperature. Temperatures are written the same way we give a temperature. Water boils at 100 degrees Celsius. That's a temperature. Ice melts at 0 degrees Celsius. That's a temperature. Celsius degrees are the number of degrees between two temperatures. They're written differently. Water boils at 100 degrees Celsius. That's a temperature. Ice melts at 0 degrees Celsius. That's a temperature. But between them, there are 100 Celsius degrees. So now you can see that it goes 100 space Celsius degrees. So Celsius degrees, we're talking about degrees. 0 degrees Celsius, we're talking about a temperature. So there are 100 Celsius degrees between 0 degrees Celsius, that's a temperature, and 100 degrees Celsius, that's a temperature. But between 0 degrees and 100 degrees, there are 100 Celsius degrees. That's all I'm going to say about that. Just watch the videos over and over and over until your eyes bleed. If it's not making sense, please call me or show up to one of the Zoom meetings. This is one of those concepts that 5 minutes of conversation, it's like, oh, I get it now. It's totally a stupid and horrible thing to have to learn, but it's important in science. Wind chill, if it's cold and it's windy, you'll feel colder than if it was just cold with no wind. And you use the wind chill chart. And on the wind chill chart, in the columns, there's the air temperature with Celsius on top. So this would be 4 degrees Celsius. This would be 40 degrees Fahrenheit. And then along the side, 4 degrees Celsius. I was going to say along the side, the rows indicate wind speed. So 32 kilometers, 20 miles an hour, 48 kilometers. So if it's calm, the wind chill, there's no wind chill. If it's 4 Celsius and it's calm, it feels like 4 Celsius. If there's a 16 kilometer an hour breeze, a 10 mile an hour breeze, and it's 4 Celsius outside, it would feel like 1 degree Celsius. Heat index combines humidity with temperature. You just use the chart and you look on the chart to find the temperature. So if it was 110 degrees out, and the relative humidity was 5%, then the temperature would feel like 101 Fahrenheit, or rather 101 degrees Fahrenheit. Okay, now I'm going to talk briefly, because like I said, there's a longer video that goes into way more detail. I just wanted to give you the high points so you have some idea what the hell I'm talking about once you watch the longer video. Controls on temperature. Why is it hot some places? Why is it cold other places? That's average temperature, temperature range. Some places it's the same temperature January and December, along the tropics. And as you move away from the tropics, the range increases, the difference in the temperature between summer and winter. It's cool to be high. High altitude is cold. High latitude, up by the poles, it's cold. So the main temperature controls, I'll just keep saying 95% of everything we'll talk about in this class is because of latitude. Latitude affects temperature, average temperature and temperature range. Next up is land-water heating differences, or continentality. That is such a big topic, I'm just going to leave it for the other video. Ocean currents, right. If you're on the west coast, there's a cold current, so you might be a little cooler than on the east coast where there's a warm current right offshore. Elevation, higher elevations have colder temperatures. You know, people go skiing in the mountains where it's high because it's cold. High elevations are cool. So for average temps, so this is all the months added up and then averaged out, and you can see it's pretty much just latitude. As you move north, it just gets colder and colder and colder, and there are some exceptional places: the Rockies, the Appalachians, the Andes. Right in here, you can see it's dark red, so it's super hot, and then it goes to the lighter red, and then even that yellow, meaning it's like two different colors colder. Two different colors colder in the Ethiopian highlands. This right here, this blue area is the Tibetan Plateau. If I zoomed in a whole bunch, you could see the Alps. You could see the mountains in Scandinavia. Yeah, it's pretty good. So it's mainly latitude as modified by elevation that's modifying the average temperature. The temperature range is going to be a function of latitude here along the equator. Very low temperature range. As you move away from the equator, the temperature range, in fact, going across the flat plain states, you can see the range just gets bigger and bigger and bigger and bigger. So temperature range is going to be a function of latitude and continentality. The farther inland you go and the higher in latitude you go, the bigger the temperature range. So the highest range in the world is up here in Siberia, where the prevailing winds are coming from the west. So this is as far inland as you can go, and it's about as high latitude as you can go. You can see the southern hemisphere has very low temperature ranges because this is the Tropic of Capricorn. So that's 23.5 south. There's really nothing. This is 30 degrees. 30 degrees. This is 30 degrees. So you're like the middle of California. Yeah. And here you are almost running out of South America. So temperature range, it's latitude and continentality. The farther you are inland, in fact, across the U.S., it's even more obvious that the coast has a lower temperature range, higher temperature range, higher temperature range. The highest temperature range is smack dab in the middle of the U.S. So now we're back to average temperature, a different look. You can see the high places are cold, high places are cold. The Rockies, they're cold. Average temperature across North America, you can see the Sierras are cold, the Rockies are cold. The Appalachians, you can see it's a little bit cooler right in here because there's higher elevation. Temperature range, again, latitude is the predominant factor, followed by continentality for temperature range. So now we're back to the US for temperature range, and you can see as you move inland, the temperature range gets higher. As you move towards the poles, the temperature range gets higher. And I made this map because I thought this one might not be enough for some of you to actually get the difference. Yeah, like the whole West just looks brown. And so it might be hard if you're unfamiliar with the physical geography of North America. It wouldn't be fair of me to ask you questions about, well, is it high elevation or high latitude that's creating this temperature range? So I included this. The yellow parts are the highest. The purple parts are the lowest. So here you can clearly see the Appalachians, the mountains in central Mexico, the Rocky Mountains, and the Sierra Nevada, going up into the Canadian Rockies up here. So the yellow places are high, the green are second highest, going down into blue. So we've got the Appalachians, the Rockies, the Sierra Nevada, the Central Mexican Cordillera. Appalachians are high, Rockies are high, Sierra Nevadas are high. Central Mexican Cordillera is high. Okay, I wanted to talk briefly about rounding temperatures. The other video I talk about rounding temperatures, rounding numbers, but rounding numbers is something that I should talk about more. So, the quick and dirty, because this is the quick and dirty guide, the answer has to have the same number of decimal places as the question. So if I asked you, hey, what's 20 degrees Celsius in Fahrenheit? The answer would be 68 degrees Fahrenheit. It's an integer. If the question is an integer, the answer is an integer. If I gave you 20.2, if you convert 20.2 using the formula to convert into Fahrenheit, you get 68.36, but the question had one decimal place. The answer has to have one decimal place. That's 2. So you gotta, if it's a 6, you get rid of it and add 1 here. So that would be 68.4 degrees Fahrenheit. If I gave you 20.22, that works out using the formula to 68.396 degrees. But because the question had 2 decimal places, you got to round that up. And this is super duper important. If the question starts, however many decimal places the question has, the answer has to have that many. 68.40. Well, it was 68.396. That rounds to 68.40. Really 68.4, but it's not 68.4. If you put 68.4 on the test, that's wrong. You just got rid of the precision of that hundredths place. So if the question has 2 decimals, the answer has to have 2 decimals, even if it's a 0. Even if it's a 0, even if it's a 0, keep it so that the answer has the same number of decimal places as the question. Okay, if you're seeing this video, you probably already saw the other video. I'm not really sure what the best order to watch this is, but there's a formula that we will be using to convert back and forth between Celsius and Fahrenheit degrees and temperatures. But it occurred to me, because we're Americans, and I'm assuming most of us grew up not learning the metric system, the rest of the world grew up using the metric system. The rest of the world uses the metric system. Everybody but Liberia, Myanmar, and the US uses the metric system. So really, what you're probably going to come across most often is Celsius temperatures. Right? You're not going to come across Fahrenheit temperatures because the rest of the world, when they do science, uses the metric system. So you're going to be seeing Celsius temperatures. And it would be good to have an easy way of looking at those numbers, because the rest of the world uses Celsius. We don't. It would be good to be able to look at a temperature and go, well, 30 degrees Celsius, do I need shorts or a parka? I don't know. So there's a quick and dirty way of converting back and forth, converting from Celsius to Fahrenheit. So this class, we're going to use the metric system. What I'm about to teach you, and there's a brief 8-question quiz. It's just converting Celsius to Fahrenheit. And the key is remembering the tens and then fudging in between, which I know makes no sense yet. Hold on. Okay, so -10 Celsius equals 14 degrees Fahrenheit. So these are all temperatures. 0 Celsius, 32 Fahrenheit. So every time you go up by 10 Celsius degrees, you're going up by 18 Fahrenheit degrees. Every 10 Celsius degree change, so 10 Celsius degrees, is an 18 Fahrenheit degree change. So at 10, going from 0 Celsius to 10 Celsius, we're adding 10, so we should add 18. So 18 and 32 is 50. So 10 degrees Celsius is 50 degrees Fahrenheit. 20 is 68. 30 is 86. 40 is 104. That's going to cover just about all the temperatures you'll be exposed to. In fact, just going from 0 to 40 for Sacramento, that's going to be almost all the temperatures that you'd ever be exposed to. So that's what I mean by the tens. And for me, well, you need to memorize 0 is 32. And from there, it's pretty easy just to start memorizing, well, 10 is 50. So if 10 is 50, if you go up 10, 10 goes up to 20. 50 goes up by 18 to 68. So 20 is 68. Go up by 10, go up by 18, go up by 10, go up by 18. Okay, so every time you go up 10, you're going up 18. So every time you go up 1, you're going up 1.8. So Oh, and 50 is 122. Yeah, I hope to God we don't need to use that this year. So you remember the tens, and then in between those tens, you just go, well, 1 Celsius degree equals 2 Fahrenheit degrees. So here's what I mean. So if I give you 25 degrees Celsius, you'd go, well, 20 is 68. Okay, so 20 Celsius is 68. So this is 5 degrees more. 5 times 2 is 10. So 10 plus 68 would be 78. So 25 Celsius is approximately equal to 78 Fahrenheit. So for the quiz, all I want you to do is take the integer Celsius temperatures and convert them to integer Fahrenheit temperatures using this system. Remember the tens, fudge in between, 1 Celsius degree equals 2 Fahrenheit degrees. And it's pretty close. So here's the actual formula. 25 Celsius times 1.8 plus 32 gets you 77 degrees. So our quick and dirty was 78. The actual answer is 77 exactly. But again, because the question was an integer, the answer is an integer. It just worked out that it works out to exactly 77 degrees even. Yeah, I'm going to do another one. So 17 Celsius. So 10 Celsius is 50. So you could start there and go, well, 10 is 50, right? So then we're left with 7. 7 times 2 is 14. So 17 Celsius is 64 Celsius. And the actual answer was 62.6. It's close enough. Like I said, this is just so you have, right. The whole point of this is hopefully by the end, you'll be able to look at a Celsius temperature and have some clue what that would feel like in Fahrenheit. That's the whole point of this. So pretty accurate. Remember the tens, fudge in between with 1 Celsius degree equals 2 Fahrenheit degrees. We just did 17. Oh, right, but there's 2 ways, right? So 17, it's actually closer to 20, right? So the closer you can use the 10, the closer the 10 is to your temperature, the more accurate it's going to be, because it's only 3 degrees away from 20. It's 7 away from 10, but 3 away from 20. So you could go, well, 20 Celsius is 68. So we're 3 degrees cooler than 68. 3 times 2 is 6. 68 minus 6 is 62. And the actual answer was 62.6. So you can, just pick the 10 Celsius degree temperature that's closest to the Celsius that I give you, and then just fudge in between with 1 Celsius degree equals 2 Fahrenheit degrees. Man, I hope that made sense. I know it was pretty fast. Hopefully you can watch it through a couple more times. If you have any questions, please come to Zoom. Again, this is one of those topics that like 5 minutes of conversation, the light bulb goes on, and you're good to go. Yep, that's it for this quick and dirty intro to Lab 4. I hope you do well in Lab 4. I hope it's not difficult. If it's difficult, just stop what you're doing and then come to the Zoom sessions. Send me an email. We'll set up something. That's it. I wish you good luck with Lab 4.